All right, we're going to get started with this week's Fridays with Narelle. Today we are going deeper into synthetic vitamins and why it's always better to get your vitamins and minerals through whole food sources. So what we're going to learn today is all about the minerals in vitamin supplements. So what may not be surprising is that when it comes to nutrition, plants and humans actually are different. We get our nutrition in different ways. Plants, with the aid of enzymes and humic substances in the soil and soil-based microorganisms, take in from the soil the mineral salts in the soil through their roots. And after various metabolic processes, when these minerals no longer exist as they were in the soil, they don't exist as salts anymore after these metabolic processes that the plant takes them through, they become complexed with carbohydrates and fats and proteins present in the plant as part of that living organism. So basically the plants extract the minerals from the soil and convert it into food-based minerals. So therefore, for nutrition, humans eat plants and or animals that eat plants, whereas plants obtain their nutrients from the soil. So this is commonly referred to as the food chain. Okay, so mineral salts are natural food for plants. They are not natural food for humans. Humans don't have roots. Okay, we can't extract our nutrients from the soil. We have to actually pull out the plants that extract the nutrients from the soil. Okay, this all makes total sense, right? Until you get to looking at your vitamin supplement and the mineral supplements that are in your food. Okay, so many of these mineral salts that are found in food, they are called natural because they are rocks. Okay, calcium carbonate, which is a source of calcium found in our bread and our fortified cereals, it actually exists as the rock called limestone. Okay, so calcium carbonate can be produced chemically in accordance with the British Pharmacopoeia or the United States Pharmacopoeia via a chemical process. Okay, so it can either be crushed up rocks or produced chemically. So even though these mineral salts are technically natural, they are not food minerals and they are not in the form that the human body has evolved to accept. Okay, so minerals bound up in these mineral salts that are found in the soil are simply not treated in the same way in the body as minerals that are found in food. So minerals that are normally found in food are normally attached to proteins or little proteins called peptides. So when humans eat plants or animals, they are consuming minerals in these forms, that these are bound up in with organic compounds, not the inorganic compounds that are found in soils. So humans are not supposed to directly consume soil or soil components. They've never been a part of our diet unless you're eating clay for detoxification, okay? They're not a part of our diet. They're not a nutritional factor in our diet, with the exception of salt, okay? Salt, which is a mineral salt, that is the only mineral that we consume in any quantity. But all of the other minerals, that's the sodium chloride. Okay, all of the other minerals that are found in the soil, these mineral salts, we're not supposed to consume them. okay? So what the pharmaceutical industry does, as I mentioned last week, they take these mineral salts, these natural mineral salts, and chemically combine them with other compounds to try to make them more assimilable for human consumption. But they're not the same. They don't go through that incredible process of extraction from the soil by the plants. Okay, that is not replicatable. So what I'm going to read out now is minerals that we need in our food versus the industrial chemicals. Okay, so the following list describes many mineral salts and chelates or chelates, which are those compounds that the pharmaceutical industry industrially tries to convert those mineral salts into chelates and that are used in supplements to try and make them more digestible for us. And I'm going to show you what they're actually used for what they're really used for when they're not used in supplements. Okay, so boric acid is the rock known as sasolite. It is used in weatherproofing wood, fireproofing fabrics, and it's an insecticide. Calcium ascorbate is calcium carbonate processed with ascorbic acid and acetone, and it's synthetically manufactured and used for supplements. Calcium carbonate is, as I mentioned, the rock known as limestone or chalk. So when you're having your calcium supplements, the calcium carbonate, you're actually eating chalk. So it is used in the manufacture of paint, rubber, plastics, ceramics, putty, insecticides, inks. It's also used in fillers for adhesives, matches, pencils, crayons, lino, insulating compounds, and welding rods. Okay. Calcium chloride, which is another mineral found in many supplements, is calcium carbonate and chlorine, and is used by the product of the Solvay ammonia soda process. It is used in antifreeze, refrigeration, fire extinguisher fluids, and to preserve wood and stone. Other uses for calcium chloride include cement, a coagulant in rubber manufacturing, controlling dust on unpaved roads, freeze-proofing of coal, and increasing traction in tires. Calcium citrate is calcium carbonate, limestone, chalk, processed with lactic acid and citric acids, and it's used to alter the baking properties of flour. Calcium gluconate is calcium carbonate processed with gluconic acid, which is used in cleaning compounds. It's used in sewage purification and to prevent coffee powders from caking. Calcium glycerophosphate is calcium carbonate processed with D-L-alpha glycerophosphates. It's used in toothpastes, in baking powder, and as a food stabilizer. Calcium hydroxyapatite is basically crushed bone and bone marrow, and it's used as a fertilizer. Calcium iodide is calcium carbonate processed with iodine, and it's an expectorant. Calcium lactate is calcium carbonate processed with lactic acid. It's used in toothpastes, and it's used as a preservative. Calcium oxide is basically burnt calcium carbonate. It's used in bricks, plaster, mortar, stucco, and other building materials. It's also an insecticide and a fungicide. So there's a whole lot of chemically processed versions of calcium. Calcium stearate is calcium salt extracted from animal fat. It's used for weatherproofing and waterproofing fabrics, and in the production of cement, stucco, and explosives. Chromium, so synthetic sources of chromium are chromium chloride. It's used as a corrosion inhibitor and a waterproofing agent. Chromium picolinate is chromium processed with picolinic acid, and picolinic acid is a herbicide. Now let's look at copper, the mineral copper. Copper aspartate is made from the reaction between cupric carbonate and aspartic acid from chemical synthesis, and that is totally chemical process, and it's used as a mineral supplement in non-food mineral supplements. Copper carbonate is actually the rock known as malachite, and it's used as a paint and a varnish pigment, plus as a fungicide. Copper gluconate, which is also found as a copper source in our vitamins, is copper carbonate processed with gluconic acid, and it's used industrially as a deodorant. Copper glycinate is copper salt processed with glycine, and it's used for photometric analysis for copper. Copper sulfate is copper combined with sulfuric acid. It's used as a drain cleaner to induce vomiting. It's considered a hazardous heavy metal, and it can contaminate our water supply. Dicalcium phosphate is a rock known as monatite, but it can be made from calcium chloride and sodium phosphate. Ferric pyrophosphate is an iron rock processed with pyrophosphoric acid. It's used in fireproofing and in pigments. So it's a color. Ferrous lactate, which is an iron supplement. That's a preparation from isotonic solutions. Ferrous sulfate, which is the rock known as melantorite. So all of these things are just basically crushed up rocks. A lot of these things are crushed up rocks treated with chemicals. But ferrous sulfate, melantorite, is used as a fertilizer, a wood preservative, a weed killer, and a pesticide. Magnesium carbonate, which is the rock known as magnesite, that is also used as an antacid, a laxative, and a cathartic. Magnesium chloride is magnesium ammonium chloride processed with hydrochloric acid. It fireproofs wood, carbonizes wool, and it's used as a glue additive and a cement ingredient. Magnesium citrate is magnesium carbonate processed with acids. It's used as a cathartic. Magnesium glycinate is a magnesium salt processed with glycine to try and make it more assimilable. Magnesium oxide is burnt magnesium carbonate, and that is used as an antacid and a laxative also. Manganese. Now, synthetic sources of manganese are manganese carbonate, which is actually the rock known as rhodochrosite. It's used as a whitener and to dry varnish. Manganese gluconate is rhodochrosite, that magnesium rock or manganese rock processed with gluconic acid. And that is to try and make it more assimilable to humans. Manganese sulfate is from a reaction between manganese oxide and sulfuric acid, and it's used in dyeing, clothes dyeing, and in varnish production. Molybdenum, Ascorbate is molybdenite, which is the rock, processed with ascorbic acid and acetone. And that's how they make it for human consumption, process the rock. Molybdenum disulfide is the rock, again known as molybdenite, and it's used as a lubricant additive and a catalyst for hydrogenation for the wonderful production of margarine. Potassium chloride, which is a crystalline substance consisting of potassium and chlorine, and that's used in photography. Potassium iodide is made from hydriodic acid and potassium bicarbonate by melting in dry hydrogen and undergoing electrolysis, and that's used to make photographic emulsions and as an expectorant. Potassium sulfate is used as a fertilizer and is used to make glass. Selenium. Selenium oxide is made by burning selenium in oxygen or by oxidizing selenium with nitric acid. And that's used as an oxidizing agent in chemical processes. Seleniomethionine, which you may see as a selenium source in your vitamins, is a selenium analog of methionine, again trying to add bits of amino acids to rocks to make it digestible. And that is used as a radioactive imaging agent. Silicon dioxide is the rock known as agate. Very, very beautiful. It's used to manufacture glass, abrasives, ceramics, enamels, and it's a defoaming agent. So just doesn't make sense. We don't eat rocks. We've never eaten rocks. Why would we crush them up into fine particles and put them in our vitamin supplements? Why? Because they're cheap. Zinc. Zinc acetate is made from zinc nitrate and acetic anhydride, and it's used to induce vomiting. Zinc carbonate is the rock known as smithsonite or zinc spar, and it's used to manufacture rubber. Zinc chloride is a combination of metallic zinc and chlorine, and it's used as embalming material. Zinc citrate is smithsonite processed with citric acid, and it's used to manufacture some toothpastes. Zinc gluconate is zinc rock, the smithsonite processed with gluconic acid. Gluconic acid is used in many cleaning compounds. Zinc lactate is the rock processed with lactic acid. Zinc monomethionine is the rock processed with methionine. Zinc orotate is the rock processed with orotic acid. Zinc oxide is the rock known as zincite. It's also used as a pigment, zinc oxide, for white paint and as a sunscreen, which is what we use it for. We don't eat it. We put it on our skin as a sunscreen. Zinc phosphate is the rock known as hopeite, and it's used in dental cements. Zinc picolinate is the zinc rock processed with picolinic acid, which is a herbicide. And zinc sulfate is the rock processed with sulfuric acid, and it is used as a corrosive in calico printing and to preserve wood. So these are basically chelated minerals. Chelated minerals are generally the crushed industrial rocks that are processed with one or more acids. So probably the biggest difference in minerals now compared to 1947 is that some companies have decided to industrially produce versions of minerals attached to peptides. Essentially, they take a rock or an industrial mineral salt, chemically alter it, and attempt to attach it to the mineral. This results in a mineral that is different from normal mineral salts, but it does not turn the substance into a food. Examples of this are the ones that I've previously given, including the various mineral ascorbates, picolinates, aspartates, glycinates, and chelates. It needs to be understood that since these are, there is not a universally accepted definition of the term chelate, when this is used on a label, one generally doesn't know if the chelate is amino acid based or some type of industrial acid. So while it's true that humans can and do utilize minerals from chelated or chelated minerals to a small extent, they are not as safe, nor are they as effective as when consuming them from foods, okay? Or in the case of real food supplements or food concentrates, okay? So more research needs to be done regarding the ingestion of ground up rocks. They are not optimal for human health, and they do pose health risks. Perhaps it should be mentioned that multivitamin mineral formulas are in fact dangerous and have been proven so by a couple of studies and do not result in optimal health. One study involving over 38,000 women in the USA who took synthetic vitamins with ground up rock minerals found that the women died earlier than those who did not take them. Okay, so women, nearly 40,000 women were followed over 30 years, and the women who took the ground up rock mineral vitamin supplements died earlier than those who did not take them. Other studies have concluded that the acid processed rocks that we've just been talking about, that are many calcium supplements, cause kidney stones, acute gastrointestinal events, and increase the risk of heart disease and stroke. Yet those studies did not find those same problems with food calcium. Okay, so I'm just going to share with you some natural food sources. So you don't want to take those toxic food sources. You want to take natural food sources. Let's have a look. Can you see this? Okay. I'll make it bigger so you can hopefully see it. So, sodium, a great source of sodium, of course, is salt, soy sauce, vegetables. These are the macro minerals. These are the major minerals that we need in decent amounts. Chloride, which is needed for sodium, and chloride are needed for fluid balance, nerve transmission, muscle contraction. Chloride is needed for stomach acid, and a good food source is just salt, obviously sea salt and soy sauce. Potassium is needed for fluid balance, nerve transmission, and muscle contraction. And food sources of potassium are meats, milk, fresh fruits and vegetables, whole grains, legumes. Calcium, very important for healthy bones and teeth, helps muscles relax and contract, important in nerve functioning, blood clotting, blood pressure regulation, immune system health. Good sources of those are milk and milk products, although they have their issues, being acidic forming. Canned fish with bones, so salmon and sardines are excellent sources of calcium. And of course, greens, leafy greens, broccoli, mustard greens, and legumes, beans, are all good sources of calcium. Phosphorus, which is important for healthy bones and teeth. It's found in every cell, and it's part of the system that maintains our acid-base balance or our acid-alkali balance. Phosphorus is found in meat, fish, poultry, eggs, milk, and processed foods, but we don't obviously want to use, because it's a phosphoric acid. We recommend you don't get your phosphorus from soda, from processed foods. Magnesium, found in bones, needed for making protein, muscle contraction, nerve transmission, immune system health. It's actually critical for about 300 different enzyme processes in the body. Excellent sources of magnesium are, of course, berry radical, nuts and seeds, legumes, leafy green vegetables, seafood, chocolate, artichokes, and hard drinking water. Sulfur, which is found in protein, occurs in foods as part of protein. So meats, poultry, fish, eggs, milk, legumes, nuts. Now I'm going to go through the trace mineral sources. And basically these are just the sources whereby we don't need as much on a daily basis. But iron, which is part of the molecule, the hemoglobin found in red blood cells that carries oxygen around the body, and that's needed for energy metabolism. Iron is found in organ meats, red meats, fish, poultry, shellfish, especially clams, egg yolks, legumes, dried fruits, and dark leafy greens. Zinc, which is part of many enzymes needed for making protein and genetic material, has a function in taste perception, wound healing, normal fetal development, the production of sperm, normal growth and sexual maturation, and immune system health. Very important trace mineral. It's found in meats, fish, poultry, whole grains, and vegetables. Iodine, which is found in the thyroid hormone, which helps regulate growth, development, and metabolism, is found in kelp, seafood, and foods grown in iodine-rich soil, iodized salt, bread, and dairy products. Selenium is an antioxidant. It's found in Brazil nuts, meats, seafoods, and whole grains. Copper, which is its function is as part of many enzymes, and it's needed for iron metabolism. Copper is found in legumes, nuts and seeds, whole grains, organ meats. Manganese, part of many enzymes in the body, is actually widespread in many plant foods. Fluoride is involved in the formation of bones and teeth and helps prevent tooth decay. That's found in fish and teas. Basically, most teas have plenty of fluoride in it. Chromium works with insulin to regulate blood sugar, and that's found in unrefined foods, especially liver, brewer's yeast, whole grains, nuts, and cheeses. And molybdenum is part of many enzymes in the body. That's found in legumes, breads and grains, leafy greens, leafy green vegetables, milk, and liver. So you can see that whole legumes and whole grains are actually an important part of our diet. So and dairy products, whole dairy. So I'm not entirely sure about the long-term consequences of strict keto diet, but that's just my opinion. Yes, Dartsay, there there are different types of fluoride, not the fluoride monofluorophosphate that is used in our water. So that is an industrial chemical. That is a chemical byproduct. And basically, so yeah, there's fluoride found in food source, which is an important mineral. And then there's the fluoride, monofluorophosphoric acid, and all those industrial chemical fluorides that they add to our toothpaste and our water, which is actually very toxic. Now, I saw that someone's just, I think Josephine raised her hand. I'm trying to figure out how do I find this out? Hang on a tick. I'm just going to close that. Josephine, yes. What would you like to? Can you see the you can either unmute yourself, or you can type it in the message box.
Oh, I didn't realize how to type it. Okay, I was just going to ask, can you repeat what you said about the problem with the long-term ketogenic diet?
Well, as you can see from these important sources of food minerals, many of the sources of food minerals are from whole grains and legumes, and they are two food groups that are left out of the ketogenic diet. That's just my, my opinion is to leave out entire food groups that are actually whole foods. May not be in the best interest for our health and well-being long term.
I get you. Thank you. So I have a second question. What do you think about using Epsom salts for transdermal absorption of magnesium?
Absolutely, no problem. And magnesium chloride, whatever we could absorb through our skin, no problem. Yep. Fantastic to have a bath.
Okay, thank you.
Yeah. So that's the bottom line. Food sourced vitamins and minerals are how our bodies have evolved, and no amount of chemical treatment of ground up rocks is going to be better than food. Nothing's going to be better from obtaining our vitamins and minerals from plants, basically, and animals that eat plants if you eat animals. So yeah, we're not designed to eat crushed up rocks. We're not designed to, when we can't absorb them. We don't have roots. Okay, so that's the bottom line, folks. And ways to basically, if you see the mineral source and then it's some kind of picolinate or citrate or some kind of salt, that's basically what they're doing, is that they are taking the crushed up rocks and treating them with acids and chemical processes to try and make them more assimilable by the body, but they will never be as good as food grade minerals. Okay, so that's our session for this afternoon, for this week. I'm going to try next week. I've got it down as fulvic acid, but I only want to do the fulvic acid if it's actually in stock. So we're still waiting on packaging. So if we have, I'll let you know during the week. If it's going to be fulvic acid, I'll let you. If it won't be fulvic acid, either way, I'm going to let you know. I'll let you know as soon as I know what next week's going to be, and we'll advertise it. Okay, so it'll either be fulvic acid or it'll be diving deeper into the supplement industry. Okay, thank you very much for being on the call. that's I look forward to seeing you next week. And yeah, thanks for joining us. Any other questions before we go?
Thank you, Narelle. See you next week.
Okay, great. Thanks, everyone. Really appreciate it.
Actually,
have a great weekend. Yes.
Can I ask a question?
Yeah.
So, is it possible that there are better mineral supplements than the different grades of mineral supplements?
Well, the major distinguishment is it from food or is it from ground up rocks? If it's from ground up rocks, it's not how our body has evolved to get our minerals from.
Okay.
So I'll see if I can do some more research into other types of mineral supplements, and
it, like, what happens if someone actually can feel the difference even when taking those ground up rocks? I think I lost you, sorry. Sorry, Narelle, I lost you.
I think you'll find that most people are mineral deficient.
I dropped out. Was Gary saying something?
Yeah, I didn't hear it. Sorry, I didn't hear. Gary, what do you have to say? Sorry.
I'll try again. Sorry. Most people, in my experience, are mineral deficient, and they may ideally long term they would get their minerals from a food source.
We're not catching that really well, Gary. If you can type it in, if it's possible to type it in the chat. While Gary's doing that, Josephine, I hear your question, and I'll do an analysis on different types of mineral supplements, because there are a few different types out there. So I'll either do that next week or I will do fulvic acid. Gary, are you typing?
Sorry, guys, I'm driving.
Yep. Okay. No worries. Okay. Maybe if you can, when you can, if you can send a message through Facebook or HQ, and we'll add your comment, or you can add your comment to the recording. That'd be great. Because yeah, we're not. It's not good audio for some reason.
No, put it on Facebook, Gary.
Yeah, that'd be great. All
Awesome.
right. Well, thank you, everyone. Really appreciate you being here. Much better than just me sitting here doing it on my own.
Was it last week on your own?
No,
Oh, okay.
It wasn't. But no, I've done it on my own before. It's definitely not as fun. Okay, loves. Thank you very much. And see you next week.
Thanks, Narelle.
Thank you. Bye.
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 Bye-bye.